Well, now we're doing the review for section 8.1. And as you know, polar form has the form r theta. And what's the alternative? Well, it's rectangular form. So we have this polar form, and we're going to rewrite it in terms of rectangular form. So it says, let's see, we've got a radius of -1 and actually the radius is always positive, so we're going to deal with that negative and -pi/3. So let's take care of the angle right now, and this would be about -pi/3. And so the radius of this circle happens to be 1. And how do we deal with that negative? Well, we're going to go in the opposite direction, and then it will become positive. And so, in so doing, we wind up at 2pi/3. 2pi/3 and a radius of 1. So, there's more than one way to write this point that they gave us. This is another way, except now we've written it with a +1 in the radius position. And how did we do that? We took the initial ray and we changed directions. Now, this ordered pair is the angles theta equals 2pi/3. So then the ordered pair xy equals cosine of 2pi/3 sine of 2pi/3. The radius is 1, and so the cosine of 2pi/3 is -1/2. And the sine of 2pi/3 is √3/2. And now we've written the initial offering in rectangular form. Now let's do number 2. And so, let's see, we're going over 1, down 1, over 1, down 1, and that'll put us right here. And clearly this is a 45-degree angle, or pi/4, but let's do it analytically. We'll look at rise over run, so tan theta equals -1/1, which equals -1, and so the inverse tan of -1 gives us theta, and theta equals the inverse tan of -1, which is -pi/4. So now we know what theta is. All we have to do is find the radius, and the radius equals the square root of 1 squared plus -1 squared, and that's going to be 1 plus 1, which is the square root of 2. So our radius equals the square root of 2. That means that we get the polar coordinates √2 -pi/4, and we're done.